So we have our mean, which is 8. Okay. Our mean is 8. Okay. And our standard deviation is 3. And our sample size is 36. We are asked the probability. Now, we asked this probability, but have we been given the distribution of the population? No, we don't know. Okay, then we just have to check the sample size. Is it at least 30? Yes, it is at least 30. Therefore, we can use the central limit theorem. And the central limit theorem just tells us that this distribution is actually normal. Okay. Okay. Yeah. So the distribution is normal. So we now go ahead to find the z value for 7.8 and z value for 8.2. So we know that to find the z value, we just get the mean, the sample mean minus the mu, okay, and we divide by that, which is the standard error. Okay, so we have our standard error there. Okay, I think I didn't do that nicely. Okay, so we have our standard error there, which is just a 3 minus 36. Okay, and that is also our standard error down there, and we have a different. Here the mean was 8.2 and there we have 8.8. So what we're just doing, we're standardizing, and here we find a minus 0.5 and a 0.5. So we're looking for the probability that z is between 0.5 and a minus 0.5. At this age, you know how to find the probability when we're using a standard normal table. So this is just the probability that z is less than 0.5 minus the probability that z is less than minus 0.5. Okay, so these are the two, the area that we're looking for. So we should find this from our table. Okay, so we're going to do with this when we start talking about confidence intervals. So for now we can, Okay, so we have discussed the sampling distribution of sample means. We have seen how to find the mean, the standard error, which is just the standard deviation of sample means, and how to find the probability. To find the probability, we have two cases. If the population is normal, then even the sampling distribution will be normal. And the second case is that if the population is not normal or it is unknown, then we check the sample size. If it is at least 30, then it means that we're going to use the central limit theorem, which just says that if the sample size is at least 30, then the sampling distribution is approximately normal. Okay. So we now move to the sampling distribution of a sample proportion. How can we estimate a proportion using a sample proportion? Now, a proportion is just the portion of a population having the same statistic, okay, or characteristic. Yeah. So having the same characteristic. So that is our sample proportion. Now we can use this proportion to actually estimate the population proportion. To find the proportion, we're just getting the number of items having the same characteristic and dividing by the sample size. Now we notice that our proportion will always be between 0 and 1. Now a proportion has a binomial distribution, but if our sample size, if we multiply the sample size by the proportion and we also multiply it by 1 minus p, and we find that it's greater than 5, then the sample proportion will be normally distributed. So unless this condition is achieved, then it is binomial distributed. If this case is achieved, then it is normally distributed. Okay. So we want to see how to find the mean of the sample proportion. The mean, also known as the expected value of the sample proportion, is just given by the proportion, the population proportion, P. Okay, and to find the variance of the sample proportion, we're just saying it's P multiplied by 1 minus P over N. Okay, and the standard deviation, we're just going to square root there. We're going to square root the variance. Now, we say that if we get N multiplied by P multiplied by 1 minus P, if that is greater than 5, then it is normally distributed. Okay, now how do we change it? How do we find the Z value if our sample proportions are normally distributed? We just get the sample proportion, subtract the population, and we divide by the standard error. The standard error in this case, which is just a standard deviation now of the sample proportion, is just the square root of P, 1 minus P divided by N. I'm sure by now we should be seeing what is happening. We always get the first, in this case, we're getting the sample proportion and we are subtracting the population proportion and dividing by the standard sample proportion. In the case when we're dealing with the mean, we got the sample mean divided by the population mean, and subtracting the population mean, and we divided by the standard error. In concept, we are just actually doing similar things. Okay, let's have our example. If the true proportion of voters who support a proposition A is 0.4, what is the probability that a sample of size 200 yields a sample proportion between 0.4 and 0.5? So this is our question. Okay, so maybe the first step is to check if N multiplied by P multiplied by 1 minus P is greater than 5. Okay, so we should be able to do that. Our N is 200 multiplied by 0.4. Then we multiply by 1 minus P, which is just a 0.6. Okay, we find 48. So 48 is greater than 5. So that means our sample proportions are normally distributed. Okay, if they're normally distributed, we can now use the normal table. Okay, so we first find the Z value. To find the Z value, we get the proportion. Okay, and we subtract the population proportion and divide by the standard deviation of the sample proportions. And as you can see, we found it earlier here. So it's the one that we use to divide there. Okay, so we have a 0.03464. Okay, now when we do this, when we standardize, we're going to find the Z values. We find the 0 and the 1.44. So we are actually just finding the probability between 0 and 1.44. Now from the standard normal table, we can find the probability the probability to the left of 1.44. So we can find that on the table, and then we are going to subtract this area here. We know this area is just 0.5. Yes, just 0.5. So then you can subtract from the area, from the probability you get from the table. Okay, so when you get that probability, your answer should be 0.4251. So that is how we find the probability when we're dealing with a sampling distribution of sample proportions. Okay, so we'll end here, and finally we're going to look at how to find the sampling distribution of sample variance. Thank you.